Hi, everybody. I'm Paul Swangart, and welcome to Form Factor Mission Central, dedicated to exploring today's semiconductor world and its exciting trek into the future. Our first mission takes us into the realm of advanced packaging, where we'll discover how it's enabling a whole new universe of applied technology, from AI to virtual reality and beyond. While advanced packaging enables a brilliant end run around Moore's Law, it also requires sophisticated fabrication techniques and a whole new approach to test and verification. We've asked Mike Slessor, FormFactor's CEO, to share his insights into advanced packaging and where it's taking us. Welcome to the show, Mike.
Thanks for having me, Paul.
So, Mike, let's get started. As Moore's Law slows, the industry has begun to turn to advanced packaging techniques to drive ongoing innovation. Briefly, what is exactly advanced packaging?
As you know, Moore's Law is slowing pretty rapidly, and the semiconductor industry being a source of innovation and innovation that ends up in all of our daily lives, from our cars to our mobile phones to our PCs, even our thermostats in our home. The basic technique is to take what used to be one chip on one piece of silicon and break it up into smaller pieces. For example, a microprocessor, breaking it up into a processing unit and the memory. That allows our customers to optimize each of the individual blocks or chiplets or tiles, as they're called, for their specific job. For example, the CPU on one process technology, the memory on another process technology, and then bring them back together after the wafer fab in these advanced packages to build this new innovative high performance product. Essentially, advanced packaging is the process by which we disaggregate these products and then put them back together to create brand new semiconductor products for all kinds of interesting applications.
What types of applications are currently driving the growth in advanced packaging today?
You've probably all heard now of generative AI and large language models that are driving really interesting applications and exciting applications like ChatGPT. It turns out to get the basic computational horsepower behind those engines like ChatGPT requires a tremendous amount of semiconductor power. Things like the GPUs from NVIDIA, the high bandwidth memory that goes with them from manufacturers like SK Hynix, Samsung, and Micron. Each of those requires advanced packaging to make those systems work at the performance, cost, and power consumption points they need to do the incredibly intensive computations behind the scenes for something like ChatGPT.
So given all that, how does advanced packaging impact chip production and testing?
Well, you can imagine if you're taking something that you used to build on one piece of silicon on a wafer and breaking it up into multiple wafers and multiple chiplets, there's some pretty significant implications for the manufacturing process. For FormFactor, focused on test and measurement, it turns out that the verification of each of those chiplets, making sure that they're good before they get stacked together in an advanced package, is a very important part of that manufacturing process. The assembly of these chiplets, typically stacked vertically with innovative new connection technologies like through silicon vias, like copper to copper hybrid bonding, have profound implications all throughout the semiconductor supply chain. One of the things you can imagine is that if one of these chiplets in a stack of 4, 6, 8, sometimes even 12 chiplets is bad, that has the potential for that one bad chiplet to essentially make the entire advanced package collection of chiplets bad.
How has FormFactor stepped up technologically to address the complexity of this advanced packaging?
One great example where advanced packages is being used in very early R&D is silicon photonics or co-packaged optics. And this is a really interesting fusion of electrical test and optical test for us. It's an area where we've made some significant investments and are now seeing the beginning of production as co-packaged optics in the data center to enable AI reduces the power consumption associated with those data centers. And it's significant amount of power being used in all of these intensive artificial intelligence applications Co-packaged optics can help that, and form factors helping enabling that energy reduction and a greener compute industry. In the probe card space, you can imagine that if you're going to do a better job of testing these individual chiplets and driving higher speeds, higher powers, higher voltages, and higher currents through the chip, that it's going to need to be a more capable probe card. The probe card, as I said before, essentially the connector between the test equipment and the chiplet or wafer. And as a result, the complexity of that connector, the probe card, is going up. We're now building probe cards that test the entire wafer at once, over 100,000 individual probes, each about the size of a human hair, that carry an amp of current at tens, sometimes even hundreds of gigahertz signals in and out of the chip.
So I don't know if you brought your crystal ball with you, but I have to ask, how do you foresee the future of testing for these increasingly complex advanced packaging devices?
A great example is co-packaged optics, as I brought up. The fusion of bringing together electrical and optical technologies for our customers to improve essentially the power consumption and energy usage of these data centers, as things like ChatGPT drive tremendous compute intensity and therefore power usage in data centers. That's a global problem, right? When we think about the environmental impact of these things, helping to reduce the overall power consumption in the data center is something that is a great place for us to leverage our technology. And I think you're going to see more of that. A lot of people don't think about the impact of a data center, but these are significant generators of greenhouse gas and users of electrical power. So becoming a bigger piece. And any role the form factor can play in making sure that we're helping our customers build more energy efficient devices like co-packaged optics, or improving the yield in their existing devices so there's less scrap and waste in the semiconductor manufacturing processes.
You mentioned artificial intelligence, which of course is a very hot topic today. Now, can you explain further how advanced packaging contributes to AI and how AI requirements impact wafer test?
Yeah, as we talked about a little bit before, the muscle or the foundation behind AI engines like ChatGPT and Microsoft's Pilot are really the computational power provided by GPUs from customers like NVIDIA, AMD, and Intel, and the memory, the high bandwidth memory. That's the engine behind ChatGPT. And so if we think about what form factor does to help enable that and what advanced packaging does to help enable that, you can imagine that trying to put what's essentially a mini supercomputer together with these high performance GPUs and the memory associated with them needs some very high efficiency, high density connections. And that's where advanced packaging comes in. Some of the very early applications of advanced packaging we're really taking these high bandwidth memory stacks and putting them on top of a GPU or CPU, which allows very high speed and very power efficient connections between the processing unit, the CPU or GPU, and the memory itself. We're in the very early stages of this adoption, but it's an example again where advanced packaging enabling and really making a reality of the fundamental compute power that we see in some of these AI engines accessible to a much broader set of people, and form factors helping make sure that each of these components, whether it's the GPU, the high bandwidth memory, function as intended and function in the most efficient way possible, lowering our customers' costs, lowering the industry's costs, and making sure we're being as energy efficient as we can in unleashing these pretty dramatic compute capabilities like Gen AI.
Mike, I appreciate you sharing your insights in the world of advanced packaging. There is more to explore with Form Factor's Mission Central. We'll see you next time.
Thanks again for having me.